In the last video, we looked at what a proposition is, that every proposition is associated with a truth value. So for any statement, if it is either true or false, then such a statement is a proposition. Okay. And in the last video, we saw the examples of different propositions or different statements which are propositions, and some examples of a statement which are not a proposition, and why it is not a proposition. And why it is not a proposition is as simple as that, because it does not have any truth value associated to it, or it is not entirely true or entirely false. For example, x is equal to x plus 5 is an even number. This statement is true for some x and false for some x. So not in entirety it is either true or false, so it is not a proposition. But whatever the propositions that we have seen in the last video, the truth value of it is in the statement itself. Okay, so they are the atomic propositions. They are the atomic propositions that by itself it is either true or false. In this video, what we are going to do is we are going to connect different atomic propositions using operators. We are going to connect atomic propositions using connectors or operators, which is basically called as logical connectors or logical operators. Okay, and there are many different types of logical connectors. In this video, we will look at negation, conjunction, disjunction, exclusive OR, NAND and NOR. In the next video, we will look at implication and other stuffs related to implication. Any atomic proposition, say P. Okay, so what is this not P? What is not P? Okay, so if P is true, then not of P is false. Not of P is false. If P is false, then not of P is true. Okay, in case of compound propositions, how do we get the truth value of the compound statement? So, however, negation is a unary operator. In case of negation is a unary operator, so it applies on only one proposition. But the other connectives like disjunction or conjunction, they are binary operators. Okay, so in case of compound proposition, we have something called as truth table. Okay, we have a truth table. Okay, so using the truth table, we get what will be the truth value of the compound statement, of the compound proposition. So a truth table is somewhat like this. On one side you have atomic participating atomic propositions. Truth value of the compound proposition statement depends upon the truth value of the participating atomic propositions and what is the type of operators is used to connect it. Okay, and on this side you have all the different combinations possible with different every atomic proposition can take two values, true or false. So different combinations possible, like one combination is when all of them are true. Okay, one possible combination is when only one is true, rest are false. In this manner, all the different combinations will be put, and with respect to every combination, what truth value would a compound proposition statement will have, that you mention it on this side. So with respect, when all of them are true, what is the resultant, what is the effect of it will be on the resultant compound proposition statement will be there. It can be true or false. So if all of them are true, if all of the participating atomic propositions are true, then what would be the truth value? Then what would be the truth value of compound propositional statement? It can be true or it can be false. It can be true or it can be false. We will see that if these statements are combined using the logical operator conjunction, then the conjunction is such a logical operator where the compound statement would only be true when all of the participating statements are true. Okay, so this will be okay. We will see that when the time comes. Okay, so right now we are talking about negation. So let's look at the truth table of negation. Negation is unary operator. Okay, unary operator. So on this side you will have only one participating atomic proposition. So when the proposition is true, then this is false. When it is false, then this is true. So this is the truth table. This is the truth table for negation. Truth table for negation. Let's take some examples. Let's take some statements to get the feel of what a negation is. Shyam got A grade. Okay, Shyam got A grade, and so what is the negation of P would be? The negation of P would be Shyam does not get A grade. Okay, let's say Shyam got the A grade. Okay, then what is the truth value of P? The truth value of P is true. Truth value of P is true. Now, if Shyam got A grade and there is a statement that Shyam does not get A grade, it means what? It means that this statement is false. This statement is false. So when this statement, it means what? It means that when this statement is true, then this statement is false. This statement is false. Let's say that Shyam does not get the A grade. Okay, let's say that he got C grade or he got B grade. Shyam does not get the A grade. Then the statement that Shyam got A grade is false. Okay, and the statement that Shyam does not get A grade is true. So that is what is here in the truth value. In the truth value, when this statement P is true, then when this statement P is true, then this complement is false. And when P is false, then complement. When P is false, then complement is true. Okay. Let us take another logical operator conjunction, and there we can get the understanding of truth table better, because it is not a unary operator, it is a binary operator. The truth value of this compound propositional statement combined through conjunction logical connective is true only when all the atomic propositions are true. Now P can be true, Q can be true, or P can be true, Q can be false, P can be false, Q can be true, and P can be false and Q can be false. These are all the possibilities, different combinations possible. So what it is saying is this, that P and Q will be true only when both are true. Only when both are true. Only when both are true. If any one of them is false, okay, or if both of them is false, then it is false. So this is how you get the truth table. So this is the truth. So this is the truth table of conjunction. Okay, this is the truth table of conjunction. Let us take statement P, which is Satish got 95 marks in physics, and statement Q is MS Dhoni is the captain of CSK. Is the captain of CSK. The compound statement connected by the logical connective of conjunction will be Satish got 95 marks in physics. Okay. And MS Dhoni is the captain of India. MS Dhoni is the captain of India, of CSK. Let's say P is true. Okay, let's say P is true. Okay, and MS Dhoni is not the captain of CSK. It is Ruturaj Gaikwad. So this statement is false. This statement is false. Therefore, the combined the truth value of this compound proposition is what will be what. So this is true and this is false. So truth value of this statement is true and truth value of this statement is false. So the truth value of the compound proposition would be true, false, and this is equal to false. Okay, so this is how it is. So the conjunctive rule says that the compound propositional statement would only be true if all the propositions are true. Okay, this conjunctive is also called as AND operation. So how do we use this logical connective AND in the real life is that we connect when the desired output for us is that both of the propositions have to be true, then we connect them using AND connective. But in scenarios when you have many options, for example, let's say there are many options, and if any one of the option is available, then your work is done. Now think in terms of proposition. There are many propositions, and you are okay with any one of them to be true. So in case of AND, we have the compound statement would be true when all of them are true. So in the next operator, which is disjunction, in disjunction the compound proposition requires any of the participating proposition to be true. If any one of them is true, the compound proposition becomes true. So let's look at disjunction. This proposition will be true. This compound proposition, the compound proposition's truth value will be true if any one of P or Q is true. If any one of P or Q is true. Now here both are true, so this will be true. Here P is true, Q is true. True. Sorry, this is false and false. So both are false. So both are false. So this is false. There is nothing that is true, so it is false. Shall we take some examples? When you should combine P and Q as with a disjunctive operation, if the desired thing is that the person is involved in an outdoor game, okay, and there are two conditions of cricket and football. So if in any one of them, if this is true, then this is what you wanted, right? So in such a case, what you do, in such a case, we use the disjunctive logic. Okay. So if Satish, let's say Satish play cricket, this is true. Now in any case, okay, so this will be true in all such cases. In all such cases when he plays cricket, when he plays both cricket and football, or when he plays cricket but he does not play football, or when he does not play cricket but he plays football. It will only be false when he does not play both cricket or football, because that will mean that he is not involved in an outdoor game. So in that scenario, this compound proposition will give a false statement, and then you can take the action according to that. Yes. But I'm just giving a real life example of we should be using what logical of connective. Okay. So when the conjunction will be used. Okay. Tell me this. When the conjunction will be used. When the conjunction will be used. So it should be used when the desired outcome is that you should be true in everything. Then you should be using the AND operation. For example, okay, take this example. When the conjunctive will be used? Let us say that there is a student and he is required to pass every subject. There are 3 subjects: physics, chemistry, and mathematics. Now the student is required to pass in every subject. Now what I am saying is this: for A, B, and C, so there will be 8 cases in this scenario. Let me take only 2. Okay. So when you have these 2 propositions A and B, where A is Ramesh passed physics paper and B is Ramesh passed chemistry paper. Now, what is required for Ramesh to pass in the examination as a whole is that he must pass these individual papers also. In this scenario, these 2 propositions A and B, it makes sense if they are combined using a conjunction. Okay, using a conjunction. So this is A and B. So the case when Ramesh passed the physics paper, if that is true, and Ramesh passed the chemistry paper, if that is true, then only this is true. Otherwise, if Ramesh fails in any of the paper, if Ramesh fails in any paper, let's say if he fails in the chemistry paper, then he does not pass the exam. This is false. So A and B combinedly, we can say this represents that Ramesh passed the exam. So Ramesh passed the exam is equal to A and B, something like this. Now if Ramesh failed in the physics paper, or Ramesh does not pass the physics paper only, he passed the chemistry paper but he does not pass in the physics paper, then also he failed the exam. And if he does not pass in any of the paper, then he failed the exam. Okay. One more thing, in the examination, listen to this very carefully. In the examination, you should go with the truth values of the propositions and the operators connecting those propositions. Okay. Not what the English statement sounds like, because this is the silly mistake people tend to do in the examination. In the examination, you look at the statement is okay, but what is the propositional value of the statement, or what is the truth value of the statement, and the operators, and what is the rule of logic, and you get the result, and not by what the statement sounds like, if it's true or not. In the next video, we will look at, okay, so in this video we have covered negation, conjunction and disjunction. In the next video we will see exclusive OR and NAND OR, and after that we'll look at implication maybe. Thank you very much.